NASA says its Voyager One probe, the most distant human-made object in the universe, is sending usable information to Earth again.
At NASA's Deep Space Network, a strange signal cut through the static. Faint, distant, taking more than 22 hours to reach Earth. It came from the very edge of our solar system.
Now, it is one of the most significant achievements by mankind, and it happened without anyone even knowing.
The source, Voyager One, a spacecraft launched back when Jimmy Carter was president. For decades, it drifted in silence, a lonely messenger in the void. But now, that silence has been broken. Voyager's instruments are detecting a constant, low-level hum, an interstellar whisper no one can explain. The discovery has scientists scrambling, because this isn't just data. It's a mystery that could rewrite our understanding of the universe. And the most unsettling question is not just what Voyager heard, but why it's there at all. A whisper from 15 billion miles. Out in the profound, freezing emptiness, where the sun is just another bright star, something is moving. It's traveling at an astonishing 38,000 miles per hour. This is Voyager One, a machine built by human hands in the 1970s, now a lonely ghost sailing through the interstellar medium. It is currently over 15 billion miles away from Earth, a distance so vast it's almost impossible to comprehend. A signal sent from the probe, traveling at the speed of light, takes a full 22 hours to reach us, and for the last few years, that faint signal has been carrying a secret, a sound, a discovery that has thrown a wrench into our understanding of the cosmos. You see, for decades, scientists expected the space between stars to be mostly quiet. Of course, there are cosmic events. Our own sun sends out massive explosions of energy, called solar flares or coronal mass ejections, that rip through the solar system and beyond. These events cause the sparse particles in space, the plasma, to vibrate and ring out like a bell. Voyager had detected these lightning bursts before. They were exciting, but they were expected. They were temporary. After the storm passed, silence would return. But what Voyager has found now is not a storm. The thing nobody tells you is that this is the opposite of a storm. It's a constant, faint, and monotone hum. Imagine being in a perfectly quiet room, and then suddenly you realize there's been a low hum in the background the whole time. You just weren't listening closely enough. That's what scientists at Cornell University discovered when they re-examined data from Voyager's plasma wave system. In between the loud bursts from our sun, they found a steady, persistent signature, the faint hum of interstellar gas. This wasn't a roar, it was a whisper, and it was always there. The probe is literally swimming through this vibration. NASA can confirm the data is real, but they can't fully explain the source of this continuous low-level activity. The interstellar medium, this supposedly gentle rain, is more active than anyone ever predicted. This single faint sound, from a machine with less computer memory than your car's key fob, has opened up a cosmic mystery box. The sound itself is a simple fact, but the implications are staggering. It means the void isn't a void at all. It's alive with a vibration we're only just beginning to hear. This changes everything. Our understanding of how the interstellar medium interacts with our solar system's protective bubble, the heliosphere, is now being rewritten. We thought we needed a massive solar event to even measure the plasma out there. Now, we know we don't. Voyager is continuously sending back details about the density of space it's traveling through, moment by moment. It's like having a weather station in another galaxy. The old theories suggested that after a solar storm, the plasma would settle back down into quiet. But it doesn't. There's a baseline level of activity, a constant hum, that we had no idea existed. Many people are crazy about what this could mean. Is it just the natural state of plasma in the galaxy, or is it evidence of a larger unseen structure in the cosmos? The data is clear, but the answers are still billions of miles away. But this signal is just the latest chapter in a story that began decades ago, with a machine that was never supposed to survive this long. A miracle. In 1977. To really understand why this signal is so mind-blowing, you have to go back to the beginning. The year was 1977. Star Wars had just hit theaters. The world was a different place. and NASA was about to embark on its most ambitious mission ever. It was a once-in-a-175-year opportunity. A rare alignment of the outer planets, Jupiter, Saturn, Uranus, and Neptune, was about to happen. This alignment meant a spacecraft could use the gravity of each planet to slingshot itself to the next, like a cosmic game of pinball. This gravity assist technique would cut the travel time to Neptune from 30 years down to just 12. NASA built two identical probes to seize this moment, Voyager One and Voyager Two. These were not sleek, futuristic ships. Weighing just over 1,700 pounds each, they were a collection of instruments, antennas, and computers held together by a prayer and some of the best engineering of the 20th century. Their main computer had only 69 kilobytes of memory. For comparison, a single photo on your phone today takes up thousands of kilobytes. Their power source wasn't solar panels. They were traveling too far from the sun for that. Instead, they were powered by radioisotope thermoelectric generators, which are basically small nuclear batteries that convert the heat from decaying plutonium into electricity. They were designed for a 5-year mission to study Jupiter and Saturn. Anything beyond that was just a bonus. Nobody dreamed they would still be working almost 50 years later. But not all things are what they seem. The Voyagers didn't just work. They revolutionized our understanding of the solar system. At Jupiter, they discovered active volcanoes on its moon Io, a first for our solar system. They found Jupiter had faint rings, like Saturn. When Voyager 1 reached Saturn, it sent back breathtaking images of its complex braided rings and discovered that its moon Titan had a thick, Earth-like atmosphere. After its encounter with Saturn, Voyager 1's mission was complete. Its trajectory took it upwards, out of the plane of the planets, on a path that would eventually lead it out of the solar system entirely. It was Voyager 2 that continued the grand tour, visiting Uranus in 1986 and Neptune in 1989, revealing bizarre tilted magnetic fields and supersonic winds. Then, in 1990, as Voyager 1 was about 3.7 billion miles from home, the legendary astronomer Carl Sagan made a special request. He asked NASA to turn the probe's camera around one last time and take a picture of Earth. From that immense distance, our entire planet appeared as a tiny speck of light, less than a single pixel, suspended in a sunbeam. The photograph became known as the pale blue dot, a humbling reminder of our place in the universe. After that, the cameras were turned off forever to save power. Voyager 1 became a silent messenger, coasting into the void with its only remaining cargo, a message for another time or another intelligence. And that cargo, a golden record, carries the hopes and sounds of our entire world, waiting for a listener that may never come. Not so empty after all. So, what is this hum? Is it an alien signal? The short answer is no, but the real answer is far more interesting. To get it, we need to take a quick trip to the very edge of our solar system. You see, our sun is constantly blowing out a stream of charged particles called the solar wind. This solar wind creates a massive magnetic bubble around our entire solar system called the heliosphere. It's like a protective shield that deflects a lot of the harsh cosmic radiation coming from the rest of the galaxy. For a long time, we didn't know what lay beyond this bubble. Then, in August of 2012, Voyager 1 made history. It crossed the boundary, known as the heliopause, and officially entered interstellar space, the space between the stars. The probe's instruments immediately told us that things were different out there. The density of particles, or plasma, was much higher, but this plasma was still incredibly thin, a near-perfect vacuum by earthly standards. The thing nobody tells you is that even in this empty space, there are waves. Just like waves can travel through water, plasma waves can travel through the ionized gas of the interstellar medium. These waves are essentially ripples in the plasma, vibrations of electrons. Voyager 1's plasma wave system was specifically designed to detect these vibrations. It can't hear sound in the traditional sense, because there's no air to carry it. Instead, it measures the frequency of these plasma waves. Because these frequencies happen to be in the range of human hearing, scientists can convert them into audio files. We can literally listen to the hum of interstellar space. So we know the hum is made of plasma waves. That part isn't the mystery. The mystery is why the hum is constant. The leading theories suggest it could be caused by what's known as thermally excited plasma oscillations. In simple terms, even in the incredibly cold temperatures of deep space, the plasma has a tiny bit of heat, and this thermal energy could be causing a low-level, steady vibration. Another idea is quasi-thermal noise, generated by the random movements of electrons in the plasma, creating their own tiny electric fields. The problem is, neither of these theories fully accounts for the persistence and the specific monotone nature of the signal Voyager is detecting. The old model was simple. The sun has a massive outburst. It sends a shockwave through the interstellar medium, and that shockwave makes the plasma ring for a while before it fades. The analogy one scientist used was a lightning burst in a thunderstorm. But this newly discovered hum isn't a lightning burst. It's the quiet or gentle rain that's happening all the time in the background. This implies that the interstellar medium is a much more dynamic and complex place than we ever imagined. It's constantly buzzing, constantly alive with energy. And Voyager One, our nearly 50-year-old probe, is the only tool we have that can hear it. But as we struggle to understand what this signal means for science, it forces us to ask even bigger, more unsettling questions. The view from the outside. Let's just take a step back for a second. Let's talk like normal people. For decades, we've been sending probes and telescopes out to look at the universe. We've been taking pictures, measuring light, and trying to piece together the rules of how everything works. And the story we told ourselves was that space, on the grandest scale, was mostly empty and silent between the bright, noisy objects like stars and galaxies. But what if that's wrong? The thing is, this hum from Voyager complicates that picture. It suggests that the vast, dark spaces in between everything might not be so empty after all. They might be filled with a constant, low-level energy that we're only now capable of detecting. So what does this really mean for us, back here on Earth? It feels like we've spent our whole lives living inside a house, and we've only ever looked out the windows. We can see the other houses, the trees, the sky. We think we understand the neighborhood. But now, with Voyager, it's like we've finally managed to place a microphone just outside our front door. And for the first time, we're hearing the constant, low hum of traffic on a distant highway we never even knew existed. It changes our whole perspective. Are we missing a key detail about how the universe is structured? This persistent vibration, what is it a byproduct of? Is it just background noise, or is it a clue to something much, much bigger? You see, this is where science hits a wall and philosophy takes over. The data gives us a what, a persistent, inexplicable hum from the void, but it offers absolutely nothing on the why. And that vacuum of knowledge is where the most fascinating speculation begins. We're not talking about alien radio shows, but about physics so fundamental it could rewrite our textbooks. Could this hum be the vibration of cosmic strings, remnants from the Big Bang, still thrumming across the eons? Or is it the resonance of the vast, invisible filaments of dark matter that we believe hold galaxies together, a sound produced by the universe's hidden skeleton? But perhaps the most mind-bending thought isn't that it's something new, but something ancient. What if this hum has been there for billions of years, the constant background music of the cosmos, and our entire species has been utterly deaf to it? All of our history, our discoveries, our wars and wonders, played out against a soundtrack we couldn't hear until a clunky machine from the 1970s accidentally stumbled upon the right frequency. It really makes you wonder, what else is out there that we're completely blind and deaf to? What other fundamental forces or dimensions are all around us, shaping our reality in ways we can't even imagine? It's as if we've spent our existence in a single room, mapping every inch of it, only to discover it has a window we never knew existed. Voyager's journey continues into the unknown, carrying its golden record, a ghost ship with a message in a bottle. What other cosmic secrets are hiding in the silence, waiting to be heard? Like and subscribe for more cosmic mysteries.